Okay, let's go back to computer vision. Okay, again, before deep learning becomes so popular in computer vision, that is how we do image interpretation or image classification, where um, the input is the image. Okay, you need to have one module called feature extraction to extract the important pattern, and then that pattern will become an input for your learning algorithms. Okay, okay, this is the example of feature extraction approach, or image feature in computer vision. Normally this is the some of the a few approach, a few common or popular approach in extracting a feature from the image. Okay, which is this one is under this, again this is under this module, feature representation. So from the image you can use sieve to extract the features. Okay, image features. So sieve is a texture based feature. Based on it will extract the feature base, or it will extract some important feature which is represented by some figure, and that figure is actually represent the texture of the image. So that's why it is called as a texture based feature. So same goes to the GIST here, GIST, GIST. GIST is also a texture based feature, while shape contact is a shape based feature, meaning that the feature extraction approach called shape context will, the input is the image, it will extract, or it will provide the figure, the output is a figure or the numbers, and that number is represent a shape of that image, especially the region of interest. I mean the shape of your region of interest. Okay, it's called as a shape based feature because of the number is provided by shape context is represent the shape of the region of interest, while GIS and SIF represent the texture of the image, using means the output is the figure that represent the texture of the image. Okay, so this is as example of features that which have been used to fit into your classification module. So then that your classification or your machine learning algorithm manage to differentiate between others mark and others object. So means that is the data that you use to fit into your learning algorithms there. Okay. Okay, so and that is also the same that is also the same thing happen for speech processing as well as text mining. Okay, as you can see that this is an example, or this one is an example of feature extraction in speech processing. You have a spectrogram, you have MFCC, and you have a flux there, and then you realize that different field have their own different feature extraction approach. You can see that in computer vision, as you can see that in computer vision we have SIF, GIS, and shape context. And you can see that if you go for, let's say, if you are interested in speech processing, then or speech recognition, then this is three common feature extraction approach in speech processing: spectrogram, MFCC, and flux. And then if you talk about text mining, this is an example of feature extraction, which is called person, name, entity, and stemming. Okay, as you can see that different field have their own different feature extraction approach to fit into your classification module or your learning algorithms. And then again, even if you let's talk about audio, since speech processing, because speech processing is a s- one is a one-dimensional signal. Among one-dimensional signal, let's say, is speech processing. If you compare with ECG or EEG, they have ECG and ECG also have their own feature extraction approach, meaning that among one-dimensional signal also have their own different approach in extracting a features. So you can see that that's why uh, if you want to, when you are focusing on research, if your research of interest is computer vision, of course it is quite challenging for you to extend your knowledge, or if you want to go to do some research in speech, you need to put a lot of effort just to learn, because the feature itself is a quite new thing for you. Just the same thing is just a machine learning part, because the machine learning part you can use the same, meaning that the learning algorithm still similar, okay, meaning that this part is still similar. Doesn't matter you are in computer vision, or you are in speech processing, or you are in text mining. This part is similar, but this part should be something new. So that's why it's very hard for someone to mastering all these three research directions, or research or these three different research field, because they have their own different feature extraction. Even among one-dimensional feature, the one-dimensional signal application also have different feature extraction, because like I said, speech processing have their own feature extraction. And then if you go for, let's say, you tackle ECG have their own feature extraction, unless except like this one, spectrogram is a general feature where I think most of one-dimensional signal have the spectrogram. However, for example like MFCC is a feature that's specialized for speech recognition or speech processing. Okay, you will not see this feature have been applied for ECG or EEG. Okay, so that is what happened. Okay, this is what happened before we implement the deep learning. So people around the world have to, not just think about the classification module, but also you need to think about how to find the best formula to represent, or to formulate to extract a meaningful information, which is called feature, and that formula is known as a feature extraction. So that is what happened in the research world. Normally people, like for example in computer vision, they will not emphasize on this one, because this one is already just implement what artificial intelligence approach or machine learning approach that you have, the available conventional machine learning approach. But they more emphasize on finding the new formula which can, in this part, which can provide a good feature, because the good feature, for sure, if you fit into the machine learning, it will give you and a good performance of the system, because it's depend on good feature. To get a good feature, you need to find the best formula at this module, so it will provide a good feature. If the good feature is fit into your data, then the performance of the whole system become more and more accurate. Okay, that is happen, doesn't matter is it computer vision, speech processing, or text mining. Okay, again, like I said, when deep learning happen, the computer vision have skipped this module, meaning that in deep learning or deep neural network, instead of try to think about what are the good feature to be fit into your machine learning algorithm. Okay, in deep neural network, you skip this part. So then the deep learning itself, the difference between deep learning and machine learning, if you talk about the computer vision, then you see that deep learning, it's the um, the raw data, which is the image, is passed through the learning without feature extraction, like I said before. So what is the philosophy behind that? Why this is the good idea in doing the in order to towards finding the best in developing automated system to interpret the image? Why in deep learning this have been introduced? What are the philosophy behind that? Okay, that question can be answered in the idea of this thing. Okay, as you can see that, of course, deep learning come from how the neuroscience learns the behavior of human brain. Okay, as you can see that the idea is that most perceptron, which is an input process in the brain, may due to one learning algorithms. Okay, so build a learning algorithm that's mimic the brain. Most of the human intelligence may be due to the one learning algorithm. Okay, the philosophy behind it is that in our brain we only have one learning algorithm, meaning that doesn't matter any information which is come from your eyes, which is computer vision, or any information come through your ears, which is sounds like speech processing. Okay, doesn't matter, because this is a two different input modality. One is from your eyes, one is from your ears. But when our brain process, our brain will process similarly using one's learning algorithms. The words there, one learning algorithm. So from that, even I think this one from the research from Ri et al. 1992, it said that the hypothesis behind the one learning algorithm is that, let's say, this is the auditory, the brain that the brain region that process the sound or from your or from sound or voice from that which is go through the ears, there is what we call as auditory cortex, which is around here. And this research said that if you disconnect between your ears and this auditory cortex and connect your eyes with your auditory cortex, then this brain, which is especially the auditory cortex here, learn to see instead of learn to hear. So same goes to the somatosensory cortex, which is originally for the purpose of learning the information come from your touch sensor, which is your hand. Okay, if you disconnect the connection between your hands and your somatosensory cortex, and you connect your eyes with your somatosensory cortex, then your somatosensory cortex be able to learn to see instead of learn to touch, to recognize touch signal. So that's from that the neuroscience conclude that our brain have only one learning algorithm, meaning that only one classification. Doesn't matter what type of input modality. Is it a sound? Is it a signal from the touch? Is it a signal from the sound, or signal from your visual? It's be able to recognize or to do what have been given to them. Okay, so from here, then this is where the idea they develop the deep learning, because as you can see that from the raw data of visual feed into the brain, and then your brain can the auditory cortex, for example, learn to see, meaning that there's a no medium like what we do like this as before, which is this one. Okay, so that's why the philosophy behind deep learning, instead of we as human try to design the features for learning algorithm, it will be much better to let computer decide what are the best pattern to be fit into their learning algorithms. So that's why the deep learning try to remove this processing block, because then if you go into many textbook, they already call this one as what? It's not feature extraction anymore. They call it as human crafted feature. Okay, if you go to any textbook related to deep learning, then they said that before the deep learning, the conventional deep learning always use human crafted. Okay, human crafted feature means that the feature which is have been designed or crafted by human. Okay, of course that is true. This feature extraction before the deep learning have been introduced, it is having a long time. We try to find the best formula just to beat each other in research world. Try to find the best formula where it can provide a good feature and this is engineered by human. So that's why they use the term human crafted features. Okay, so in era of deep learning, then they said that once you apply the deep learning, okay, the philosophy behind the deep learning is that instead of you decide what is the best pattern for computer to learn, then let the computer decide. You just give the computer with the raw data and let the computer decide what is the best pattern to be learned, instead of you are selectively or choosing specific pattern for them, where that process is called human crafted feature or human crafted feature extraction to create the human crafted features. Okay, that is what we do before this deep learning become so popular nowadays. Okay, so that's mean this one is an example of human crafted feature in speech processing. This is the human crafted feature in text mining, and this is a example of human crafted features in computer vision. So deep learning try to skip all these things, or they try to throw away all these things, instead of we thinking about we as a human think about what is the best for computer. Let the computer decide what is the best pattern that they will choose to be learned and improve in terms of learning process. Okay, so that is the philosophy behind the deep learning. Okay, according to this research from the neuroscience. Okay, then again, I think this one I already discussed in the previous chapter. Okay, from the neurons in the brain, then it become a neural network, and that is the deep learning. Okay, again, that what is the meaning of deep learning or deep neural network is that when you are increasing the number of hidden layer, like this one you already have 2, so maybe you can have more than one. It might be 2, it might be 3, it might be 4, it might be more than for example more than 50 hidden layer So then you can consider your network as a deep neural network, which is also known as a deep learning in this syllabus. Okay, again, this is the differentiate between machine learning and deep learning. I think this picture I take from the MATLAB website. Yeah. Okay, when they talk about deep learning, is that perform end-to-end learning, by learning features, representation, and tasks directly from image. Okay, it doesn't matter from image, text, or sounds. Okay, again, I already discussed that. What is the difference between deep learning and machine learning? Is that deep learning lets the computer decide. So that's why you only have one module called deep learning. That is where actually feature extraction happen. That is where the classification happen in the same integrated network. I mean, so like I said, in the philosophy behind it is that lets the computer decide what is the best pattern for the computer to be learned in recognizing something. So that's why the feature extraction and classification are integrated in the same network over here. Okay, which is in contrast with the machine learning approach, where actually in machine learning approach, this is your machine learning, but you must integrate which human crafted features, okay, which human crafted features in this module. So you need a manual feature extraction or human crafted feature over here before you can fit the features or the most important pattern in your machine learning module or learning algorithm here, so it can have a good feature as an input, and the output is the interpretation or the label image labels over here. Okay, again, this is the difference between the deep learning and shallow shallow neural network and deep neural network. Okay, as you can see that this is what we learned in previous class. Okay, but actually both is MLP. Okay, doesn't matter is it a shallow or deep, it's still under multi-layer perceptron. But the difference is that this one is a multi-layer spectron with one hidden layer, or two neural network layers, two layers neural network, this one. But this one is three neural network, 3-layer neural network, or 2 hidden neural network. So means that the hidden layer is more than once. Okay, so now let's see what is actually happen when you are what is actually happen in terms of the performance if you are compare between this shallow network and this deep neural network. Okay, assume that you have a same number of parameter, means that the W is the number of W of this both architecture is similar. Okay, means that this one will have how many? One, I think you can count it. Means that you assume that the number of W and bias is same, but the difference is just the architectures. Okay, which one is better in terms of performance? I means that in terms of the accuracy in classifying something, which one is better? Okay, I just use the result which had been, this one is result from the previous research have been conducted. You can refer to this paper here. Okay, this result is come from that paper. They find out that okay, the purpose of this study is to compare between the fat plus short and thin plus tall, means that a shallow network versus deep neural network. So this is the size, this is the size there, the layer size. Okay, as you can see that Okay, let's go to this one. 1 time 3772. This is actually considered as a shallow network. Okay, this number is really represent the number of hidden layer plus number of neurons there. Means that this you have one hidden layer with 3772 parameter. Okay, means that the W as well as the bias, they total up with, and the parameter is 3772 under the same single layer. Okay, that's why 1 time 3772. And this is the I believe this one is implemented in text mining, because you have here the performance in terms of word error rate. So they find out that the word error rate here is 17.2%. And then once they increase the size, okay, still fixed with one hidden layer, but you are increasing the parameter here. Means that you increasing, instead of 4772 neuron, you increase to 4634 neuron, and the errors there is only reduced with 0.1%. Okay. Okay, let's take a look at these previous research which have been done by Saidi, Frank, Goli, and Dongwu. Okay, in 2011. Okay, the purpose of this study is to compare between the shallow neural network and deep neural network. Okay, or fat plus short versus thin plus tall. Okay, as you can see the result here, the performance is represented in terms of word error rates. Okay, I believe that this research have been done might be in text mining, so that's why the performance have been represented by this word error rates, meaning that the smaller percent the better. Okay, so you can see that as you can see from the result here. Okay, this is the shallow neural network, and this one is a deep neural network. As you can see that why I call it a shallow neural network, because the layer is only one hidden layer. Okay, one time, so in one hidden layer you have 3772 neuron, and then they try to increase the number of neuron and fix just increase the neuron but fix with a single hidden layer, while in this setup they are changing the number of layer, and each layer will have 2000 neuron. So you can see that the effects there. Okay, for example this one. Okay, by increasing from 3000 to 4000 in terms of word error rates here. Okay, it's make a little bit worse, because the percent here increase 0.1% as compared to this one. But once they increase more, which is 60k or 60,000 neuron in one layer, they achieve this error 22.1%, as you can see from the origin this one. Okay, just compare this one and this one. As you can see that the improvement is just managed to reduce the error with 0.4%. Okay, and you can see that it's how much here. You are multiply with 14. You are make it 4 times more. Okay, because 16k 4 times more from 4000 or 3700. Okay, just increase the neuron 4 times more than before. You just improve or reduce the error with 0.4% only. Okay, now see these two columns. One layer with 2000 neuron, 24.2, okay, which is close to this error here, because this is still one layer, one hidden layer, so it's not considered as a deep learning because it's a single layer. Now let's say you add up with two hidden layer. Each layer have 2000 neuron, means that the total number is 4000 neuron over here. Now the word error is 20.4%. Okay, imagine that if you compare with this one, because the total neuron used here 2 times 2, which is mean this is 4000 neuron, which is almost similar to this architecture. Okay, because the total of neuron here is also 4000 something. But as you can see that in terms of word error rate, or the error percentage of error, this one is better, which is 20.4 as compared to this one. Now you are keep increasing the hidden layer. From 2 you change it into 3. Okay, it will become much better there. Then you increase with 4, it become much better there. How about 5? Then it's more better than this category. Okay, so the last one, that one is 7 times 2. How much? It's a 14k neuron. 14k neuron. I'm sorry, 14k or 40,000 neuron. If you set up as a deep neural network, meaning that you are make it more and more hidden layer, and you distribute that 14,000 neuron equally to each and every hidden neuron, then you can get 17.1% error, and the total usage of neuron is only 40,000, which is less than this one. This one is 16,000, but you still get 22.1%. So it is worth to change from shallow neural network to deep neural network. Of course, it's very worth, because as you can see that just increasing the number of hidden layer and fix the size of parameter, it will improve better and better as compared to depending on one hidden layer, but you are increasing more and more neuron at that single hidden layer. So that is the motivation behind why people choose the deep learning instead of other machine learning or shallow neural network.